studios in New York City. This is Charlie Rose.
Tonight we continue our exploration into our magnificent brain with a look at multiple sclerosis. It is an autoimmune disease that affects the central nervous system. It is caused by damage to the myelin sheath protective covering that surrounds nerve cells. When damaged, nerve signals slow down or stop. This can occur along any area of the brain, optic nerve, and spinal cord. MS is most commonly diagnosed between ages 20 and 40, but could be seen at any age. It affects twice as many women as men. One of them joined me this evening. Andrea Kilpatrick is the president and founder of the nonprofit Cool Kids Learn. In 2001, she was diagnosed with MS. Also here, a remarkable group of scientists. Stephen Hauser chairs the neurology department at the University of California, San Francisco. Amit is a neurology professor at McGill University Health Center. Alfred Sandrock is an assistant clinical professor of neurology at Harvard Medical School. And once again, my friend and co-host, Dr. Eric Kandel. He is, as you know by now, a Nobel laureate, a professor at Columbia University, and a Howard Hughes medical investigator. Welcome to one and all. I begin with you, as always, Eric. Tell me what we will discover this evening.
In the last program, we considered Huntington's disease and Parkinson's disease. These are protein folding disorders that cause degeneration of the nervous system. Today we're going to consider a degenerative disease, multiple sclerosis, that has a very different cause. It is an autoimmune disease. So the immune system developed in order to protect us against foreign invaders like viruses and bacteria. And on occasion, it errs and recognizes a protein in the body and becomes the target of an immune attack. It's been obvious to many people all along that there are a variety of organs in the body that are susceptible to this kind of attack. For example, we've known that type 1 diabetes is an autoimmune disease that hits cells in the pancreas that release insulin, or Crohn's disease is an autoimmune disease that affects the bowel. It's been less obvious, although it's perfectly clear, that autoimmune diseases also affect the brain. Even though the brain has this protective barrier called the blood-brain barrier, autoimmune disease can penetrate that and attack it, and this is what we see in multiple sclerosis. What causes this immune attack in multiple sclerosis is not completely clear. There are a number of environmental and genetic factors that are known to contribute. So, for example, certain kind of viral infections make you more susceptible to multiple sclerosis. And also, if you have two identical twins and one of them has multiple sclerosis, the chances are 30% that the other one will have it. So there clearly is a genetic contribution to this. And if you have additional family members, the incidence will rise. The target of the disease is the myelin sheath. So many axons in the brain are covered by this fatty sheath that is designed to enhance conduction along the axon. There are some unmyelinated axons, but there are lots of myelinated axons in the nervous system. And if you attack that in an autoimmune disorder like multiple sclerosis, you can slow and ultimately stop conduction in those axons. Because myelinated axons are throughout the brain, you can affect many different parts of the brain as a result of the autoimmune disease of multiple sclerosis. If you hit the optic nerve, you can have transient blindness. If you hit the spinal cord or the brain, you can have sensory disturbances, you can have tremors, you can have weaknesses of an arm and a leg. These episodes vary in duration. They can last for days, they can last for weeks, and they can last for months. But you can have periods in between them in which you're relatively free of symptoms. This is more common in women than in men, but women tolerate the disease better than men in many cases. The incidence is about 1 in 1,000, and for reasons one doesn't quite understand, there is an increase in incidence both in the United States and in other parts of the world over the last 15 years. But that downer aside, there's a lot of optimism in the field, in part because of these 4 people here. We have with us Andrea, who is really the structure of the whole program. She sort of designed the program around herself. She brought with her her support team.
Right.
And these 3 gentlemen are here in order to sort of fill out what we need to know about her disorder, multiple sclerosis, and her disease specifically. So Steve Hauser is her physician. Right. He's a leading investigator of multiple sclerosis, and he brought with him Amit and Al, who are his colleagues, even though they work at different institutions. Amit studies what goes wrong in multiple sclerosis, the mechanism pathogenesis. And Al is developing new wonder drugs that really not only stop the disease, but are capable of reversing it. So there is an optimism in the field that this is perhaps the single most treatable disorder of neurological diseases. And we'll see in Andrea's case that these people not only will bring four independent perspectives on multiple sclerosis, but they have collaborated together in order to improve her clinical situation and actually reverse some of her symptoms. And obviously what is beneficial for her is going to be beneficial for everyone. So this is really providing a completely new approach to the disorder. And so she has brought with her team, right. Hopefully a dream right. team, but we'll see as we go along.
A good team, Andrea. Thank you very much. Stephen Hauser, let me begin with you. Drill down a bit in terms of understanding multiple sclerosis.
Sure. MS is without question one of the great triumphs, but also one of the great mysteries still in medicine. Why has it increased in frequency so much over the past 100 years, and why has this increase been almost entirely in women? We know for certain that MS is an inflammation, that myelin is targeted by our immune systems, and that this targeting of myelin causing inflammation and scarring occurs in a repetitive way over years. Very important, the scarring not only disrupts nerve transmission, as Eric mentioned, but it leads to a late degeneration of nerve cells. So it becomes a neurodegenerative disease in its late phases. And untreated, most people with MS develop disability. We're unable to work or walk or interact deeply with society. But that all has changed, as we will hear today. The symptoms of MS are symptoms due to the disruption of important pathways: numbness, weakness, double vision, loss of vision in one eye, incoordination, bowel and bladder difficulty, cognitive slowing. These are all symptoms of multiple sclerosis. MS is the most common cause of symptoms of this nature that arise in early to mid-adulthood. The MRI scan has really revolutionized our thinking and understanding about MS. We can actually visualize in real life a person with multiple sclerosis. The myelin is in the central parts of the brain, and this is a picture just above the ears, a horizontal photo of the brain. And normal myelin is black, and the scars of multiple sclerosis and the inflammation are in white. And here, over the course of a few years, one can see in the left upper corner the inflammation begin and then scar down and regress, and other areas begin and regress in other parts of the brain. We've learned from the MRI that most of the activity in MS occurs below the surface. People don't have symptoms. They may feel unwell. Fatigue is an important symptom. But over the course of time, this can lead to a progressive degenerative process. And the great news is that if we can stop the inflammation early, we can protect people against this late degeneration.
I assume you have asked this question before, and so I ask you, what answers have you found? Why more women than men?
That's one of the great unknown questions. 100 years ago, MS was as common in women as in men. In the 1950s, it was 2 to 1. By the 70s, 2.5 to 1. And now new cases are more than 3 to 1, women to men. What has changed? We think that smoking is different in women who have MS than women who don't. They're more likely to smoke, but that is a confounder, which means that it's a marker of hundreds of different behaviors. Women have changed, certainly in Western societies, in terms of their life experiences over the past 100 years. We are all reaching puberty earlier in life, and that has been happening for the last 100 years. And we know that MS disease activity in women is very influenced by the activity of hormones. So these are all clues, but currently we don't have the answers.
This is just remarkable. It has to do with research. It has to do with the hope for cure. It has to do with gender differences. It has to do with genetic implications. It has to do with environmental factors. I mean, this. If you want to say, give me a disease that reflects all of the dilemmas and the opportunity and the hope for medical science, this is one. Finally, I always do this at the end of the day, and we have many that have just sprinkled up in the conversation. What's the one question you'd most like to know the answer to?
Amit mentioned it earlier. I would like to know what triggers MS at the very beginning.
Same for you?
Well, since Steve's taken that,
yeah, no, he took yours.
I'll go for the understanding the biology underlying progression.
Yeah. So what starts it and what makes it progress?
Mine would be the trigger to figure that out. Because I know that I have history in my family, but I know that that's not determinative. So I want to know what was it about my experience.
Yeah. Mine would be, can we actually repair the brain? And, you know, there are these inhibitory proteins for some reason that not only prevent myelination, but also prevent axonal regeneration. Why they're there, it's not clear. Maybe they were important during development, but they're certainly maladaptive once you have disease. But if we can repair the central nervous system, and we all know what happens in the aftermath of stroke or spinal cord injury, and MS is certainly no exception. But if we can repair the central nervous system, and we're just starting phase 2 trials with anti-lingo later this year, so we may know the answer to that very soon. If we can do that, I think it would just open up neuroscience to a whole new era.
Why do women get it so much more frequently than men, and what is responsible for this enormous increase in incidence in the disease? This is happening with the number. Depression is on the rise. What, cosmic factors are determining the incidence of a disease? That's